we'll discuss about beats. So beats are basically the result of interferences of waves. That means मेरे पास बहुत सारी waves हैं. जब ये सारी वेव इंटरफेयर करेगी और एक वेव प्रोड्यूस करेगी, दैट विल बी कॉल्ड अ बीट. फॉर एग्जाम्पल हम म्यूज़िक सुनते हैं तो उसमें बहुत डिफरेंट बीट्स होती है, तो वो वेव्स होती है विद डिफरेंट फ्रिक्वेंसीज और विद सेम फ्रिक्वेंसीज जो इंटरफेयर करने पे एक बीट प्रोड्यूस करती है. S is equals to S1 is equals to A cos omega 1 t, S2 is equals to A cos omega 2 t. Say this is equation 1, this is equation 2. Applying superposition principle, we'll get S is equals to S1 plus S2. That will be A cos omega 1 t plus A cos omega 2 t. S is equals to A is common, cos omega 1 t plus cos omega 2 t. Again applying trigonometric property, I will get 2A cos omega 1 minus omega 2 t upon 2 cos omega 1 plus omega 2 t upon 2. So this is a mathematical expression for the beats. Now we'll study about Doppler's effect. This is related to the change in frequency. When we are an observer and a train passes, then the train is away from us. तो हमें ट्रेन की जो आवाज़ सुनती है वो बहुत लो सुनती है, लेकिन जैसे जैसे ट्रेन हमें अप्रोच करती है तो हमें जो इसकी आवाज़ है वो ज़्यादा सुनना शुरू हो जाती है. सिमिलरली हम एक और केस ले सकते हैं. ट्रेन इज स्टैंडिंग और वो हॉर्न ब्लो कर रही है. जैसे हम ट्रेन के पास है तो हमें ट्रेन की आवाज़ ज़्यादा सुनती है, लेकिन अगर हम प्लेटफॉर्म से दूर चले जाए तो ट्रेन की आवाज़ क्या हो जाती है, वो कम हो जाती है. सो वील स्टडी केस 1 व्हेन द ऑब्जर्वर इज स्टेशनरी एंड सोर्स इज मूविंग moving. So let us study from the diagram. Observer की position fix है. Source पहले S1 पे था. This is the source at position. Then जो source है वो shift हो गया with velocity vs and time delta t and time t node. तो t node पे source कहाँ आ गया, S2 पे. तो we'll write equation. So t1 is equals to, एट टाइम t1 सोर्स S1 पे था. जब सोर्स इस पोजीशन पे है तो ऑब्जर्वर को कितना टाइम लगेगा वो साउंड को कैच करने में, या कितना टाइम लगेगा जब साउंड ऑब्जर्वर तक पहुंचेगी, दैट इज लेंथ अपॉन वेलोसिटी. दिस इज इक्वेशन 1. जब टाइम t नोड हो गया, हेयर टाइम इज t1, जब टाइम t नोड हो गया तो वेलोसिटी, तो लेंथ क्या हुआ, लेंथ में चेंज आया L प्लस VS T नोड. सो T2 will be given by T नोड plus T नोड is the time which the source has traveled while going from S1 to S2. तो T नोड plus L plus VS T नोड upon velocity. This is equation 2. Similarly, at time t is equals to t n naught n, so we'll get t n plus 1 is equals to n t naught plus L n vs t naught upon v. Mark this equation 3rd. Now we'll calculate the difference of Tn plus 1 and T1. So Tn plus 1 minus T1 will be n T naught plus L plus n Vs T naught upon V minus L upon V. On solving this, we'll get T is equals to T naught 1 plus Vs upon V. If we talk in terms of frequency, we'll get frequency is equals to V naught 1 plus Vs upon V power minus 1, or now using binomial here, we'll get frequency as V naught 1 minus Vs upon V. So this is in terms of time and this is in terms of frequency when the observer is stationary and the source is moving. So the next case is when the observer is moving and the source is stationary. So we'll proceed in the same manner, but here is a change in speed due to the concept of reference frame, क्योंकि जो observer है वो move कर रहा है. So there is the speed is V naught, velocity of the observer, and V at which the reference frame is moving. So again we'll calculate Tn plus 1 and T1 and subtract both. So we'll get the result in terms of T and T naught. Now in terms of frequency, when we'll calculate, we'll getting this result in the same way. Now if we compare this result with the previous one, then there is no change whether the observer is moving or the source is moving. The frequency of the sound is almost same. So the third case is when the both observer and the source are moving. Initially the observer is at O1 and then it moves to O2, and source S1, then it moves to S2. The velocity here is V naught, which is the velocity of the observer, and Vs is the velocity of the screen. So from O1 to S1, the length is capital L and the velocity is V plus V naught. So from here we'll calculate T1, which is equals to L upon V plus V naught. Say equation 1. Similarly, we'll calculate T2. So from O2 to S2, length is L plus Vs minus V naught into T naught. So T2 will be T naught plus L plus Vs minus V naught into T naught upon V plus V naught. Equation 2. Similarly, we can write Tn plus 1 as n T naught plus L plus n Vs minus V naught T naught upon V plus V naught. The next step is subtracting Tn plus 1 and T1. So we'll get n T naught plus L plus n Vs minus V naught T naught upon V plus V naught minus L upon V plus V naught. On getting this, on solving this, we'll get T is equals to T naught V plus Vs upon V plus V naught. So this is in terms of time period. In terms of frequency, we'll have mu is equals to mu naught V plus V naught upon V plus Vs. So these were the three cases when the source is moving, when the observer is moving, and when both source and observer were moving. So this was all about Doppler effect and waves. We'll see you in the next video. Till then, keep revising.